Our keynote speaker is Mark Simos, lead cybersecurity architect from Microsoft. At Microsoft, Mark leads the development of cybersecurity reference architectures. Personally, I refer that architecture a lot. And he also leads the best practice, reference strategies, prescriptive roadmaps, and other guidance to help customers rapidly secure their organizations in the digital age. And Mark will talk about practical cloud security, increasing attacker cost, and adopting the shared responsibility. All right, let's welcome Mark. Mark, all yours.
Thanks, Brian. Much appreciated. So as Brian mentioned, we're going to talk about practical cloud security and what we find works well, specifically around two different themes about increasing the attacker's cost, essentially disrupting their return on investment, the attacker ROI, and adopting the shared responsibility model. And so let's start with a very common anti-pattern. An anti-pattern is basically the opposite of a best practice. It's something that we commonly see, but it tends to be counterproductive and it tends to be unhelpful. And so many organizations believe that attackers are going to follow the path that they have laid out. They put in firewalls and IDS, IPS and DLP and all these controls that, hey, the attackers will have to come through this path. But the attackers are smart. They're human too. And they will look for the easiest way to get to their goal, because their goal isn't to get in your network. Their goal is to get into your business assets of interest. And so what the attackers actually do is they pick the path of least cost or least resistance. So they look for the easiest way to get to their objective. And so what defenders must do is look at what everybody already knows, which is strong security controls, but they also have to look at the placement of those controls to make sure they're actually covering the real paths that attackers take. And of course, having a rapid response to attacks so that the attackers, if they do get in, are able to be caught and found and evicted or kicked out very quickly. And of course, continually testing and monitoring those controls so we're not operating on assumptions, we're operating on real world data of what actually works through penetration testing, red teaming, vulnerability and cloud posture management tools, and the like. So let's take this out to a little bit more of a specific technical example of how this happens. So attackers are going to very quickly be able to determine, hey, this organization has a next-gen firewall, they have intrusion detection and prevention, they have DLP, they have some of the basic controls in place. I'm not going to go for a scan and exploit at their network at edge or their network egress point. So what attackers often do, and this is something we see quite a bit, is that let's send an email to their IT admins and saying, hey, we've got a higher paying IT admin job at this other organization. And take control of their admin workstation. And oh, look, we found passwords.xls that has all the service account passwords that have access to all sorts of things within the environment, including the data that I have interest in, that I want to steal or encrypt for ransomware or what have you. So that is what we very often see when we talk about that path of least resistance that the attackers can take. And they didn't have to compromise the firewall or the IDS or the DLP or any of those kind of things. They just simply went through a different path. So how do you address something like this? How do you look at the attacker cost and make sure that the attacker doesn't have a really cheap path that they're going to use every time because it works? So first of all, you want to make sure that the assets of interest are themselves protected. So the sensitive data, the important data is actually protected and monitored so that you can detect and block attacks on it. We also want to make sure that that passwords.xls process is replaced with something more modern like a privileged identity management, privileged access management. In the case of Azure, workload identities provide system managed accounts and secrets. Protecting privileged accounts. These privileged accounts have access to the assets, the human accounts, the IT admins, etc. Let's go ahead and make sure they're using dedicated workstations that are not used for email and browsing and the like, and that they are strongly protected with multi-factor authentication and the like. Excuse me just one moment. And then let's go ahead and make sure that we are applying security hygiene and best practices related to patching rapidly, making sure that the configuration of things meet security standards, baselines, benchmarks, and that the operational practices are also following best practices. So you're not logging in with this super powerful domain admin, global admin, etc. account on the same workstation where you're actually clicking on email every day as part of another part of your job. And then, of course, we want to make sure that the monitoring and response processes aren't just focused on the network, that we are looking at anomalies at the identity level, at the application level, at the data level, so that we're able to detect these other paths that attackers take that don't really show up as different network traffic, but they show up as different usage of an account or a different usage of an application. And so we want to spot anomalies at those different layers. So ultimately, here's an example of what cost of attack looks like if you look at it through a low, medium, high, or very high lens. So we've taken one particular example, which is logging into an account. So at the low level, you've got a password-based logon. We do not recommend this in any scenario. So password only is not very secure. It costs on the dark markets, I want to say, I think it's like $1 per thousand, if I recall correctly. Compromised username and passwords, and on average, about 1% of the, if you have like a fairly large, million password dump, about 1% of those will work in any given organization because guess what? People reuse passwords, and if that password was compromised somewhere else, they're going to try it with your corporate ID. And so we see about a 1% hit rate. So we do not recommend, because of how cheap it is and how easy it is for attackers, that you ever use a password-based logon. MFA has gotten very cheap, very inexpensive to deploy as a defender. So that medium level, strong MFA, account session risk is monitored through something like Azure AD Identity Protection. And then, of course, having the security operations team monitor and respond to alerts of those account abuse that doesn't match pattern. So that really is kind of the baseline we recommend for standard users. Moving to the high level, this is where you start taking accounts and not treating them as one large population, but let's go ahead and tag the individual high value accounts of interest that are IT admins that have control over the Swift money transfer terminals or whatever happens to be valuable at your organization. And so let's tag those and make sure that security operations has extra monitoring and quick response for those that prioritize it, puts it at the top of the queue. And then, of course, very high is switching to a secure by default mode where effectively the account can't do anything except what it is supposed to be doing. And this is really for IT admin service accounts and other fixed use, very high impact accounts. And so each of these steadily raises the attacker cost. So it costs you a little bit in terms of the defender effort to go ahead and bring it to this level, but for certain roles, you're going to elevate them all the way. You're going to want to have a good, strong baseline at least that medium level for users, etc. So we have found that cost of attack is one of the most useful ways to prioritize how you're investing in defenses. So let's take one more step deeper into this. So when we look at cost of attack, ultimately different attackers are going to have different thresholds. These are just general levels on the right, but ultimately amateurs that are just kind of doing it for the laughs or the lulls or whatever, they're going to have a fairly low threshold because they're very opportunistic and don't really have a lot of motivation on that. Organized crime, where there is a profit, there's an explicit monetary return on investment. If you all have been paying attention to the ransomware space, it's somewhere in the order of, depending on how you add it up and estimate it, some of the gangs have either hundreds of millions or even billions of dollars in profit from ransomware extortion payments. So a very high profit industry, which gives them a lot of budget. Now, they're not quite as persistent as a nation state, because a nation state is going to care about you specifically as an attacker if they are targeting you as an organization. But ironically, sometimes the organized crime has a higher budget than the nation states, but they also have less focus and persistence because organized crime is going to go to the easiest and cheapest target. So anyway, so the cost of attack really plays into their threshold of when they will go and do something else. And ultimately, as a defender, your job is to spend your budget to raise their cost of attack, to make it harder, to increase friction, increase literal cost if they have to buy a 0-day or whatever the case may be, but make it harder for them to do their job. And we have found that actually zero trust ends up getting you more bang for the buck when you apply these types of principles of assuming compromise and building your defenses accordingly. We're going to lose accounts. We're going to lose endpoints. We're going to lose web servers. Let's make sure we have a process to reclaim them quickly. Let's make sure that if they get that, they don't automatically get domain admin, global admin, and beyond. So that having that assumption of compromise or assumption of breach, verifying explicitly. Let's not just assume that they're on the network so they're good. Let's go ahead and explicitly verify the account, the device they're using, etc., before we let them have access to resources. And of course, least privilege, not just from we don't give more people than need to be admin rights, but let's also make it just in time and make them ask for them each time so that their accounts aren't sitting there with extra privileges that they don't need all the time. So, we really see zero trust as a major enabler of taking those security investments and getting more out of them. So now let's switch modes for a moment here. Let's get into the shared responsibility model, because this one is super, super important for organizations as they go to the cloud. So the shared responsibility model, that little blue and gray blocks there, ultimately is a reflection and a planning model for how the world actually works when you're hosting some of your workloads on cloud. This is something that we didn't have to deal with when everything we had to secure was sitting on-prem in our own data center, and we literally built the facility and owned it in most cases, and then physically put in the racks, and then physically wired up the power, physically wired up the networking. And literally everything about securing that was on us as an IT and security department. That was our job. When you introduce a cloud provider who put up a data center, put up either an app or a VM platform or platform as a service, PaaS services, all of a sudden we didn't do that. We didn't provide ping, power, and pipe to it anymore. We actually were providing, that the cloud provider did that, and we are doing part of that. And so the shared responsibility model is really to formalize and describe that relationship. And it is different. The reason I mentioned SaaS, PaaS, and IaaS separately, as well as on-prem, is because the shared responsibility and where the line is drawn, again, it's specifically per service, but generally PaaS providers are similar, IaaS are similar as well. That line is drawn differently. So software as a service, most of it's done, and all you have to do is configure that service well, make sure you have a strong identity going into it, provide strong identity infrastructure that you're using, whether it's Azure Active Directory or Active Directory or Ping Federate or whatever it happens to be, the devices that your users use, and then the data on it. So you have a very short list of things you have to protect, which at first is scary because I have to trust the cloud provider to do all the stuff that I've been the expert on forever. But it becomes very powerful because I have a shorter list and I can do that list much better than I can a full long list where I have to worry about firmware on the servers, the operating systems on the servers, the applications on the servers, the middleware on the servers, the agents on the servers, and beyond and beyond and beyond. And so, platform as a service is a little bit deeper. There's more because these are essentially software as a service for an app, and all the things that the app does, you have to worry about, as the developer, the people that secure what the developer does. But the actual operating of, the database service or the machine learning service or whatever is the cloud provider's problem. And then infrastructure as a service, your list is longer. Not quite as long as running your own physical servers, but it's longer than software as a service or platform as a service. But this really helps in a couple of ways. One is it helps you understand what you have as a to-do list technically, but it also helps transform your mindset that, hey, partnership and security can be good. Now, we've had partnerships in security sometimes before, and often they were built around a service provider who was trying to provide the least cost service, whether it's an MSSP or IT service outsourcing or whatever, and it was used and focused on lowering cost, right, and doing this as simple as possible or as cheaply as possible. And so the cloud partnership is very different. The cloud partnership is actually driving the organization forward, not holding it back, because the cloud provider is providing new functionality without being asked to, without having to renegotiate a contract. It's just, hey, there's a new service in Azure. Hey, there's a new service in AWS. Hey, we added a feature to this. We added a feature to that. And so it's a very different partnership than the ones we've had with outsourcing in times past. Now, let's get into this a little bit and talk about kind of some of the details of how this breaks out. We'll do this one fairly quickly so we have time for some of the other topics. But ultimately, fundamentally, the cloud provider always secures the fabric, and then the usage of the cloud is always yours. That's pretty much the constants across the shared responsibility model. Now, when you look at the different service type, it varies between infrastructure, platform, or software as a service. And it's key to keep in mind that software as a service is running on somewhere. So it's either on a set of data centers that SaaS provider does, in the case of Microsoft, or it's running on somebody else's platform. So there's many software as a service applications that are running on AWS, running on Amazon, etc. So just kind of keep that in mind in the back of your mind. Usually doesn't affect your decisions as using that application, but it is just a truth behind the scene. Now, when it comes down to, say, policy and compliance and applying regulatory stuff, cloud providers pretty much own the physical, the network, the software security across all that. But reporting compliance for the workloads that you are hosting on-prem and on the cloud is always on you. And then many of those things that I mentioned earlier, the accounts, the information and data and documents that you have, the devices and the browser security, all those are still on you, and making sure that the devices that you issue or that their users are using are properly managed, properly secured, etc. And then of course there's the variations depending on whether it's IaaS, PaaS, and SaaS. Now, the interesting thing is that shared responsibility is not restricted to cloud itself. We became very, very acutely aware of this as an industry as organizations adopted the cloud. So people think of shared responsibility as a cloud-only thing, but it actually is more. Shared responsibility relationship exists with the software developers who make patches and then we apply them. Varying relationships, we'll cover that in a moment. And there also is a shared responsibility between your teams within your organization. And so we'll use the example a little bit later about doing detection and response, essentially SOC monitoring, for DevOps style workloads. And so we'll talk about how shared responsibility works between your teams in addition to you and a cloud provider, you and a software developer or vendor. So continuing on with the cloud theme, let's go ahead and take a couple more views of it. The most common anti-patterns that we see with cloud is the most common one that we see. We don't see these a lot, but we want to make sure that you're warned, is expecting the cloud provider magically does everything. This is actually not true. Cloud providers do a lot of it, but they don't do everything. And oftentimes, especially in the case of Microsoft, and I think Google does this a little bit, security capabilities also come from the cloud provider that help you with those blue blocks, those responsibilities of yours. So a lot of investment from the Microsoft side to help with that, but it does not do everything for you. And then occasionally we do see this, fairly rare, I almost include this almost for humor reasons, is we do sometimes see that organizations believe that they can secure better than the cloud provider can. And hey, we need to see your raw network traffic. We need to see this and that and these other low-level things that we're used to using and we're used to looking at to do our analytics, which is I want the raw traffic. And as a cloud provider, we cannot provide other traffic and data that has other customers' data, and it doesn't work. You wouldn't want us sharing that with somebody else either. So we do see these two extremes more often than not, the left one. But it's really important to understand that shared responsibility model where things begin and end is the best practice there. And then within the organizations, we often see that siloed teams don't talk or work together. And so there's these communication gaps. Sometimes there's overlaps. And ultimately, we do see a lot of challenges there within organizations, which is one of the reasons we're starting to build these shared responsibility models like you'll see in a little bit. But ultimately, you want to have a cultural support that, hey, we want these teams to work together. The most effective teams that we see, bar none, are the ones that are working together. The IT and the security and the business stakeholders are working together, working things out, looking at security risk, looking at IT and operational uptime and efficiency, looking at the business requirement and balancing among the three. That is the pattern that we see works really, really well, is when folks are encouraged to, incented to, and are working together. That actually works a lot better than IT and security fighting against each other, which is all too common. So one of the last couple points here is when you're working with a cloud provider, really two different priorities here. One is to implement that shared responsibility model. You know, the strategy, the planning, the process controls all need to be adjusted as you realize that some stuff is done by them, some stuff is by us. So we may have to adjust scripts or controls or what tools we use and processes, how we assess risk, how we report on compliance, etc. So it really does touch a lot of what we do in security. And then, of course, we do have to trust the cloud providers as a customer. And so let's make sure that we're doing our due diligence. Let's look at all of the mandatory regulatory things that they have to file and share to achieve all of the different regulatory compliance things like FedRAMP and SOC Type 1 and Type 2 and all those kind of things. I completely blanked on compliance compliance names there for a moment, but making sure that you're reading that. There are extensive things, and in the case of Microsoft, our Service Trust Portal has an extensive set of documentation where you can see how we do things, how we structure our program and controls and the like. And, you know, this is a quick summary of what those look like for Microsoft. So in Microsoft's case, you know, traditional defenses and many ways of looking at it from an attacker's view. Those, as I mentioned earlier in the beginning, sort of the pen testing, red team, and the other ways of showing that rigor. We do put a disproportionately high level of effort at Microsoft into protecting privilege access. This because there's a big difference between losing one sheep and losing the shepherd, and therefore the whole flock. We want to make sure we do not lose admins or privileged accounts, so we put a lot of effort into the people, process, technologies to protect them. And of course, into the code itself, making sure that that code is secure and that, you know, we are doing a secure version of DevOps as we're developing these capabilities for the cloud, etc. And then, of course, our version of security operations, we call it our CDOC. It's much more of a fusion center than a single SOC, where multiple teams that monitor multiple environments work together. And where I mentioned earlier, the documentation, the Service Trust Portal, those links will provide you that. And so we'll provide those afterwards. So taking a quick look at some of the other versions of the shared responsibility model, as you can see here, that green rabbit zone at the top, where it's a cloud service or one of those little iPhone apps that automatically updates itself and goes to a little circle before it launches, or when you change your processes to make sure it patches by default instead of waiting until an approval or a testing that never happens, tend to be the best ones. Then there's sort of the turtle ones, which require a lot of manual effort. And then the red dinosaur zone there at the bottom, kind of the lava pool, where quite frankly, there is no patch because it's unsupported, whether it was released yesterday or 30 years ago. There's a lot of those kinds of apps. Of course, in Log4j, we found a lot of hidden places where all these components that need patching could be hidden. So just kind of keep in mind, it's not always an obvious thing that sits in your configuration management database or CMDB. And, you know, just want to touch on this really quickly. What we found when we look at this sort of DevOps process, looking at almost through a lens of DevSecOps, is it's a partnership. You need to have the workload owners, often represented by the developer, sometimes an application owner, etc. They have a big piece to play in keeping their application secure, as does the people that are operating it. And this might be the ops part of a DevOps team. This might be IT operations in a central way, etc. And then, of course, security operations that is doing the monitoring and response. And so we found, depending on which task needs to be done, there is a different shared responsibility relationship. So security incident management tends to be the SOC, whereas at the application layer tends to be heavily a mix of the owner and security, sometimes with the operations team mixed in terms of remediation recovery that would cause a reinstall of the application. And then the operating system layer that is underneath it, or the container layer that is underneath it, tends to be a little bit more of a generic infrastructure. So it's more of an ops security relationship or an owner security and ops relationship. And so this is just looking at the detect and respond side, not so much the prevention side. So wanted to kind of share this learning here for your education and enjoyment. So summing this all up, ultimately, we would recommend that you prioritize your security investments, not only using your own cost and budget, but also the attacker cost, and focus on that disrupting of the attacker ROI by increasing their cost. And that helps focus on the defenses that are both practical and effective, as well as cost effective and cheap. And then, shared responsibility model, embrace it, use the power of it, and adjust your processes, technical capabilities, your skills and knowledge, because this will be one of your greatest tools in succeeding. We have also some resources where we talk about this at a program and strategy level. We've got some more modules that we're working on now to follow up on this, but this is the CISO level workshop. So about 4 hours of videos, 16 videos in total, including the download of PDF downloads of the slides. And so you can go ahead and check that out anytime you want. If you want to get a delivery of this at your organization, you can talk to your CSAM, your customer success account manager, and we'll be happy to figure out how to get one of those delivered for you. A lot more resources at a list that I maintain called Mark's List, and of course I'm on Twitter and LinkedIn as well. So with that, I think I'm done. I thank you very much for your attention, and I'll hand it back over to Brian.